let's go to page 533, and this is lesson 8.4. And this lesson is to learn about properties of rhombuses and rectangles and squares. Okay. So it says, in this lesson, you will learn about three special types of parallelograms: rhombuses, rectangles, and squares. So a rhombus is a parallelogram with four congruent sides. So all four sides are congruent is a rhombus. Whereas a rectangle is a parallelogram with four right angles. So here all four sides are congruent. Over here all four angles are congruent. Okay. Now it says a square is a parallelogram with four congruent sides and four right angles. Okay. So a square is a special rhombus. A square is also a special rectangle. Okay, now here are some corollaries about the properties of each one of those special parallelograms. Okay, rhombus corollary. It says a quadrilateral is a rhombus if and only if it has four congruent sides. Now, if and only if means it's biconditional. Now, biconditional means the forward is true and backward is also true. Okay, because some conditional statement is not true if you reverse the statements. Okay, but if and only if means if you go forward it's true, and if you do the converse means go backward is also true. So what it's saying is that if it's a rhombus, it has four congruent sides, and if it has four congruent sides, then it's a rhombus. So both ways are true. Okay. Now this one over here is about the rectangle corollary. Okay. A quadrilateral is a rectangle if and only if it has four right angles. So again, okay, if it has four right angles, then it's a rectangle, and vice versa. If it's a rectangle, it has four right angles. Okay. So again, if and only if means it can go both ways. Okay. Now for squares, it says a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay. So again, if it's a square, then it's also a rhombus and a rectangle. And the converse is, if a quadrilateral is a rhombus and a rectangle, then it is a square. Okay. Okay, now let's go to the page 534. So this is how it sums up the shapes. So all the parallelograms can break into three categories, right? So you can have actually two categories. Okay, the rhombuses, okay, all four sides are congruent, and rectangle, all four right angles, all four angles are congruent, right? All the right angles are congruent. So all four sides are congruent, all four angles are congruent, which means they have to be right angles. Okay. Now the square is a special rectangle. That means all four angles are congruent, all four angles are right angle. But square is also part of a subset of the rhombus. Okay? A square is also a rhombus because all four sides are congruent. Okay. So this kind of picture helps you to visualize how does different shapes, categories fit together. Okay. Okay, now let's go to example 1. Okay. Use properties of a special quadrilaterals. Okay, example 1. For any rhombus QRST, so over here, so QRST, it says decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So if you have QRST and you want to find out if what's the relationship between angle Q and angle S. So if you have quadrilateral, okay, a rhombus, so over here is a rhombus. So you have a rhombus, so you got Q and S. Okay, so the answer is always congruent because a rhombus is parallelograms, and parallelograms opposite angles are congruent. Okay, so answer for A would be always. Okay, so opposite angle will always congruent. Whereas angle Q congruent to angle R, so angle Q congruent to angle R, the only situation, so it's sometimes. Okay, like in this case, it's not congruent, but in this case they are. Okay, so answer is sometimes they're congruent, and that sometimes when it's congruent is when it's a square. Okay, so again, if rhombus QRST is a square, then all four angles are congruent congruent right angles. So angle Q congruent to angle R. If QRST is a so again they are congruent if it's a square. Because not all the rhombus are also squares, the statement is sometimes true. Okay, so again, so like if you have just a regular rhombus but it's not a square, then the two consecutive angles are not congruent. Okay. Now let's go to example 2. Classify spatial quadrilaterals. Quadrilateral means 4 sides, right? Quad means 4, lateral means side, right? So quadrilateral means 4-sided. Okay, classify the spatial quadrilaterals. Explain your reasoning. So from this, you can see that all 4 sides are congruent, so right away it's a rhombus. Okay. Next, you check your angle. Okay, are all 4 angles right angles? Answer is no. So therefore, it's not a rectangle. Therefore, it's not a square. So this is just a rhombus. Okay. Again, solution. The quadrilateral has 4 congruent sides. Okay, one of the angles is not a right angle, so the rhombus is not also a square. Okay, by rhombus corollary, the quadrilateral is a rhombus. Okay. Okay. Let's go to page 535. The theorems below describe some properties of the diagonals of the rhombuses and rectangles. So theorem 8.11, a parallelogram, the definition of parallelograms is has 2 pairs of parallel sides. Okay? A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if the diagonals are perpendicular, and again, if and only if means you have to go both ways, right? Both ways are true. So if it's a rhombus, the diagonals are perpendicular. And converse of that, if the diagonals are perpendicular, then it is a rhombus. Okay. Over here, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So again, if it's a rhombus, then the diagonal will bisect all the angles. The opposite angle get bisect, the opposite angle get bisect. Okay? So again, if it's a rhombus, the diagonal will bisect the angles. And converse is also true. Okay? If the diagonal bisects the angles, okay, then it is a rhombus. Okay, theorem 8.13, a parallelogram. A lot of this is kind of seems like a lot of things to remember, but just kind of use your common sense, and you can kind of figure it out. So if you don't remember, just draw a nice picture, and kind of just reason it through. Okay. Okay, theorem 8.13. A parallelogram is a rectangle. Okay, if and only if its diagonals are congruent. So again, if it's a rectangle, the diagonals are congruent. Okay, and converse. Okay, if the diagonals are congruent, then it's a rectangle. Okay. Okay. So now let's go to example 3. It says list properties of spatial parallelograms. So sketch a rectangle ABCD. This everything you know about it. Okay. Okay. So by the definition, you need to draw a figure with the following properties. Okay, the figure is a parallelogram. Again, if it's a rectangle, the opposite sides are parallel, opposite sides are parallel. So that's what the definition of a parallelogram means. Okay, the parallelogram means opposite. Two pairs of a parallel sides. Okay, so you got this pair a parallel, this pair a parallel. Okay, and you have 4 right angles. So again, rectangle has 4 right angles. And because ABC is a parallelogram, it also has these properties. Okay, so again, opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Okay, and over here, opposite angles are congruent. So opposite angles are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Okay, so again, a rectangle. Now this is only for parallelogram, but remember this is it also for the rectangle, right? So for rectangle, the consecutive sides are supplementary, but in this case, they are also congruent, right? And over here, the diagonal bisect each other. Now, since they already bisect each other, right, that's for parallelograms. But if it's a rectangle, not only they bisect each other, okay, they're also congruent. See, they bisect each other, but they're also congruent. So again, just kind of go over, make sure you know all those facts about different shapes. Okay, let's go and review a little bit about biconditional. So page 536. biconditionals. Recall that biconditionals such as theorem 8.11 can be rewritten as two parts. To prove a biconditional, you must prove both parts. So conditional statement. If a diagonal of a parallelogram are perpendicular, then the parallelogram is a rhombus. And the converse. If a parallelogram is a rhombus, then its diagonals are perpendicular. Okay. So again, so when you combine this together, it becomes biconditional. So again, biconditional, bi means two, right? Conditional, again, it means that under certain condition is true. Okay. So again, biconditional means that both conditions will be true. Okay. Now to prove this one over here, okay, if the diagonal of parallelograms are perpendicular, okay, so again, that's a simple rhombus perpendicular, then the parallelogram is a rhombus. Okay, so to prove that it's a rhombus, remember, rhombus has all four sides congruent, right? So you have to kind of work thinking backward. Okay, you have to work backward. So rhombus has four sides, all four sides are congruent. Okay, so you have to prove all four sides are congruent. But again, from your experience, to prove something congruent, you have to use a CP/CTC. And in order to use CP/CTC, you have to prove that triangles are congruent. So you can see you kind of reason backward. So what you want to do is first you have to prove that triangles are congruent. Then you can use CP/CTC. Okay. Okay. So what you want to do is, since they're perpendicular, right? And you know that it's a parallelogram, right? So parallelogram, the diagonal bisect each other. Okay, so since they bisect each other, that means this will congruent to that. Okay. Okay, so and you can use the reflexive over here. So you're gonna have the SAS. So these two triangles are congruent. And if these two triangles are congruent, then these two sides are congruent. So you can use CP/CTC. So now if these two sides are congruent and these two sides are congruent, that means all these three sides are congruent. Okay? And also remember, opposite sides are congruent for parallelogram, right? So this is congruent to this, and this is congruent to that, and congruent to that. So that's how you prove all four sides are congruent. Okay? So again, first you have to prove that these two triangles are congruent, or any of the two triangles are congruent. And again, to prove that, you use the diagonals bisect each other. So you can see that these two sides are congruent, and this is reflexive, right? The bx equal to bx by itself. So you're gonna have a SAS. Okay, so that's how you prove that two triangles are congruent. And after that, you can prove that two sides are congruent because of CP/CTC. Okay, again, so if once you get to that part, once these two sides are congruent, and remember these two are congruent, right? Because opposite sides are congruent for parallelograms. So these two are congruent, and this is congruent to that, and this is parallel. These are two are congruent, therefore this is congruent to that, and simple for that, and that's how you prove. Okay. Okay. Now let's go ahead and do this one here. Example 4: solve a real-world problem, carpentry. Okay, so carpentry actually uses a lot of geometry, okay, and a lot of measurements. You are building a frame for a window. The window will be installed in the opening shown in the diagram. So you have this opening over here. And so the top is 33, the bottom is 33, the side is 44, the side is 44. Okay? Okay. So the opening must be a rectangle, right? Again, you want to be a straight rectangle. Give the measurement in the diagram. Can you assume that it is? Okay. So with the given measurement, okay, can you assume it's a rectangle? The answer is no, because it can be slanted a little bit and it becomes parallelogram. Okay? So B, you measure the diagonal of the opening. The diagonals are 54.8 and 55.3. What can you conclude about the shape of the opening? Okay? So again, so this is not a rectangle. It looks like it, but it's not a rectangle because the diagonals are not the same. So it kind of slant a little bit. So it's actually a parallelogram. Okay? Okay. So solution. Part A, no, you cannot. The boards on the opposite side are same length, so they form a parallelogram. But you do not know whether the angles are right angles. Okay? So you cannot assume that it's a rectangle because you don't know the angle. And so B, by theorem 8.13, the diagonals of the rectangles are congruent. So if it's a rectangle, the diagonal should be congruent. Okay? The diagonals of the quadratic formed by the board are not congruent. So you got 54.8 and 55.3. So they are not congruent. So therefore, it's not a rectangle.